but he's in great shape, right? Yes.
If we end up with something like that, do you think we've done it wrong? Like, will they usually come out to be pretty nice?
They should come out to be nice.
Okay.
I'm not saying that they will. It really depends on who's in charge of putting your test together. If it's an advanced teacher, they think that's nice. If it's a teacher who's actually taught your class, they make it nice. Make sense? I don't know who put together your test for this. Okay, we gotta do, here's what I would like to do. I would like to do one concavity problem with a point of inflection. And I would like to do, I'm hoping to get to a fence. Yes?
Where do you think that X is?
Here. Before I took the derivative.
And that gets you
Time.
the minimum time?
Minimum time. So far, so good? Yes?
What is this the square root over 21?
Well, because there is no square root of 21. It doesn't come out nice.
Oh, that's right.
3, 7. Okay. Okay. We need to do a concavity problem, at least one. I think one should be enough to show you what you need to know. And then we need to do two implicit differentiations, some sequences in series, and hopefully get to your fence problem, Josh. Okay. Does anyone have the math lab practice test with them?
I do.
Yeah. Copy.
We're all using.
This is happening on Saturday.
Well, your last test, begin the last test in one.
Okay, we're going to do number 15 for the practice test. Okay, now there's a whole bunch of questions on your test that says which of the following statements is true, but on your actual exam, it'll have that same question, but you'll only have one type of answer. So they'll all be concavity, or they'll all be maxes and mins, or they'll all be vertical asymptotes, etc. Does that make sense? So you're not going to have to try like 100 different things to figure out which one it is. Fair? Okay, I picked this one because the answer comes out ugly and because it has an E. Fair enough? Okay, we have a product rule. We're going to say find where f of x is concave up. Okay, so my f prime of x is equal to 2x e to the negative x plus x squared negative e to the negative x.
Concave up.
I'm pausing for a moment. Moment over. Okay, I'm going to factor out e to the negative x. So that I don't have to do two product rules, I can just do one product rule. I am lazy. Derivative of the first times the second plus the first times the derivative of the second. Oh, we're just going to set this equal to 0. I'm going to factor out e to the negative x because I can, and because it never equals 0, and it doesn't give me any information. So far, so good? You guys have that terrified look on your face that I have when I'm trying to do econ.
We are doing econ.
I am doing econ. No. Okay. So far, we're okay? So I have e to the negative x, x squared minus 4x plus 2. Okay, what are two things that multiply to 2 and add to negative 4? Nothing. Which means we have to use quadratic. Oh, brutal. Yeah, I feel you. Okay, I can't do that, or you won't be able to see. If I erase this part, is that okay, guys?
Yep.
I just can't put it up, or you won't be able to see what we just did. And I can't put it on the next board, or it won't be on the video. Like, you won't be able to see both parts on the video. So, let's do this one. And this is equal to 0. So we're going to need to do opposite of b plus or minus the square root. B squared minus 4ac all over 2a.
I still sing this song.
I don't know there's a song.
Pop goes weasel. Come on. You should know it. Just kidding. I'm just kidding.
Okay, b squared is 16 minus 4. A is 1. C is 2. Oh, b, I'm sorry, that needs to be positive 4. Okay, so we'd have 4 plus or minus the square root. 16 minus 8 is 8 over 2. Now, I picked this one for a couple of reasons. Occasionally, you have to use the quadratic equation, and I want to show you how to simplify if you do, okay? The square root of 8, I'm going to put it over here. I think of it like this. 4 and 2. 4 times 2 is 8, right? And then you can just square root each individual part. What's the square root of 4?
2.
Okay, so then this would be 4 plus or minus 2 square root of 2 over 2. And then you're going to break it up into two fractions. So 4 over 2 plus or minus 2 square root of 2 over 2, which is 2 plus or minus the square root of 2. Is that okay? And now we got to do our little number line test. Oh, so fun. So this is going to be 2 minus the square root of 2, and this is 2 plus the square root of 2. I know that 2 is between that, right? So I can plug 2 into this. Now notice that this is always positive. E to any number, always positive. So 2 squared is 4 minus 8. 4 minus 8 is negative 4, right? Plus 2. Negative 2, so it's negative right here. Now, the negative means frowny face, concave down. Sometimes they do 2 minuses. That's just so it looks like eyes. I just make mine cyclopses. Okay, so then I'm going to do something above 2 square root 2. Yeah?
How do you know if it's positive or negative again? What are you plugging into what?
I'm plugging in a number between these into the first
Second
derivative.
derivative.
Actually, the second derivative. I'm caring about concavity. So I can just plug in something way bigger than 2 square root 2, like 5 or 10. 5 I'm not sure about, 10 I'm pretty sure about. Is that okay?
Let's do it.
10. 10 squared? 100. Minus 40? 60. Plus 2? Positive. Very nice, happy cyclops. Okay? Then we're going to do something way smaller, like 0. So, it's concave up from negative infinity to 2 minus square root 2, and from 2 plus square root 2 to infinity. That's concave up, and it's concave down from 2 minus square root 2 to plus square root 2. Make sense? I'll give you a hint. If you get stuck and you can't find your critical numbers, what makes this derivative 0? They're in the answer. Multiple choice, right? Mm-hmm. Wherever it's changing, try those and see if those are critical numbers. Just plug them into your derivative, and it's 0. If it's 0, it's a critical number. Simple enough? All right. I like those kinds of strategies. Okay, I think we should do an implicit or two, because those are important. Something is a series, Taylor polynomials, and we'll do a fence one even if it's at the end, okay? Okay, you guys ready? My buddy on the camcorder, you want to move over here? Your favorite job ever?
Like J.J. Abrams. Yeah. Because it needs to shake more.